This is the solution video for section 5.3, problem number 12. All right, so an airplane is flying at a constant speed of 360 miles per hour and climbing at an angle of 45 degrees. At the moment the plane's altitude is 10,560 feet, it passes directly over an air traffic control tower on the ground. Find the rate at which the airplane's distance from the tower is changing 1 minute later. Neglect the height of the tower. All right. So first of all, we got to start with a picture. All right, and the picture is very important to understand some of the geometry here. All right. So we have the ground here, and we have this air traffic control tower. Now, I am drawing it right like that because it says neglect the height of the tower. So if the tower is 100 feet tall or 200 feet tall or whatever, we're just assuming it's right on the ground. All right, so we have an airplane that is flying. It left from somewhere else, and it is climbing at an angle of 45 degrees, right? So this is a 45-degree angle, right? So now it says the moment it passes over the tower, it is 10,560 feet above, right? So that's 2 miles, right? So 2 miles, okay? So this distance is 2, right? That is fixed. All right. Then it says 1 minute later. So from this point, it flies for 1 minute and it ends up somewhere over here. All right. The question is find the rate at which the airplane's distance from the tower is changing. So now the distance the airplane is from the tower is right here. So let's call that D. So we want to find the rate at which that is changing. All right. So what are the things that we have here? Well, we have D, obviously, that is changing. So there is a D, D, dt, which is some positive value that we would like to know. All right, what else is changing? Well, the distance that the airplane has traveled, right, from when it passed over the tower until the 1 minute later moment, right? And so that is a distance. All right, and so I'm just going to call that F for flown, distance flown or something. All right. So that is changing, of course. So there is a df dt, right? And that is a positive value, but we are given that. We're told that it is flying at 360 miles per hour, right? All right. So that's what we're given, right? Now, this picture, is kind of confusing now because it's like, well, what is this angle? Like, how do I deal with this? So what we actually want to do is we want to drop in the altitude here, right? And then we want to think about what we actually have going on, all right? So when I think about it, if I were to draw in a horizontal line here, we also have a right triangle there, all right? So what I'm going to do is I'm going to take out that smaller right triangle that I just drew, all right? So D is not associated with this triangle necessarily, right? F is the hypotenuse of this triangle. But remember, it was flying on a 45-degree angle. And so this is actually a 45, 45, 90 right triangle, right? So that means this is isosceles, which means that these two sides are the same, right? So now if I go to the other triangle, this larger triangle, where D is the hypotenuse of it, right? Then this longer side here, well, if you think about it, is actually just x plus 2, right? Because this is x here and this is 2 here, so the total distance is x plus 2. The horizontal distance, well, that's actually the same as the other triangle. That's just x, okay? So now, as the plane is flying, x is changing, isn't it? And so there is a dx dt that is some positive value that we do not know, but we will actually need to know that in order to find dt. All right, so now we have all that. All right, so what we actually want to do here, the strategy is to use f and df dt to find x and dx dt, and then use x and dx dt to find dd dt. So it's actually kind of a two-part problem. All right, so what do we want to find? All right, well, we want to find d dt when what is true? Well, it says when 1 minute later, right? So when t is equal to 1 minute. Now, it's important that you remember time in as 1 minute and rate as in miles per hour. That's a problem, right? So we actually want to change 1 minute into, well, how do we convert minutes into hours, right? Well, we would divide by 60 minutes per 1 hour. And so we get 1/60th of an hour, right? So that our time unit is going to be standard. All right. So how are our variables related? Well, let's start with this first 45, 45, 90 triangle I have. They are related by the Pythagorean theorem. So x squared plus x squared equals f squared, or 2x squared is equal to f squared, right? So then we would want to take the derivative, right? So if I do that, I get 4x dx dt equals 2f df dt, right? So now I want to plug in my known quantities. Well, what do I need to find here? Well, I don't know dx dt, but I'm going to need to know that, right? I also don't seem to know x or f, right? But I do know df dt. All right, so how do I find x and f? Well, if you were flying at 360 miles per hour, right, for 1/60th of an hour, then you could figure out f. How fast have you, or how far have you traveled? All right, and so f is going to be equal to the rate at which I was traveling, 360 miles per hour, times the amount of time, 1/60th of an hour. So 360 divided by 60, of course, they're divisible by 10. 36 divided by 6 is then 6. So that means that the plane has traveled 6 miles, right? And so f is 6. Well, now let's think about it. If I know what f is, then 2x squared is equal to f squared. So 6 squared, which means divide by 2. So I get x squared is equal to 6 squared, 36. Sorry, that would be 36 divided by 2, right? So 18. And so I get that x is equal to the square root of 18, or 3 root 2 miles, right? All right, so now I know x, I know f, I know df dt, so I can find dx dt. All right, so I get 4 times 3 root 2 times dx dt equals 2 times f was 6, times df dt, which is 360. So now I'm going to divide it. Dx dt is equal to 2 times 6 times 360 divided by 4 times 3 root 2. So now I am going to simplify to make this a little easier. 4 and 2 reduce here to be a 2, 1/2. 6 and 3 reduce to be a 2 here, but those 2's would reduce. So I'm actually just going to be left with, I made a mistake somewhere here, right? No, that's right. All right, so then I would be left with 360 over root 2. So I'm just going to leave this 360 over root 2, and that would be what? Miles per hour, right? And so basically all that means is that's the rate at which the airplane's altitude is changing, but also the rate at which its horizontal distance is changing. All right, and so now we're going to use that in a minute to find d dt. All right, so then I have to go and do kind of a second version of the problem, where now I'm relating d, x, and x plus 2, right? So I'm going to say, okay, well, d squared is equal to x squared plus quantity x plus 2 squared, right? And then I'm going to take the derivative. So derivative of d squared is 2d dd dt equals, okay, now what can I do here? Well, I could do a couple different things, right? I mean, either way, it's going to turn out the same. All right, so if I do this, I get 2x dx dt plus, this would become 2 times x plus 2 to the first times dx dt, right? So however you want to deal with that is fine. You could distribute the 2, distribute the dx dt, right? All right, and so now I want to plug in my known quantities and solve. All right, but here's the problem. Once again, I know x, I know dx dt, but I don't know d. Well, how do I find d? Well, I take d squared equals x squared plus x plus 2 squared, and I plug in the value of x, which is 3 root 2. So d squared is equal to 3 root 2 quantity squared plus 3 root 2 plus 2 quantity squared, right? So that means that d is equal to the square root of all of that. Well, 3 root 2, remember 3 root 2 was the square root of 18, right? So square root of 18 squared is just 18 plus, and you can't really simplify that further, so 3 root 2 plus 2 quantity squared, right? So I'm just going to leave that as d, and so that means that I'm going to put that in place of d, and I'm going to put 3 root 2 in place of x, and I'm going to put 360 over root 2 in place of dx dt. And so 2 times d times dt is equal to that stuff. So I'm going to solve for dt by dividing by 2d. So 2d, or sorry, dt is equal to 2x, so 3 root 2, times dx dt, which is 360 over root 2, plus 2 times 3 root 2 plus 2 times dx dt, which is 360 over root 2. All of that divided by 2d, so 2, and then I have the square root of 18 plus the quantity 3 root 2 plus 2 quantity squared. Right? Now, of course, you could do a little bit of simplification here. Of course, like 2, those reduce. And then I have 3 root 2 times 360 over root 2. So those root 2's would actually reduce. These ones do not, though, because the 2 doesn't have that. All right, and so then, of course, you could do this kind of calculation here. 3 times 360 plus 3 root 2 plus 2 times 360 over root 2, and then divided by that denominator, square root of 18 plus the quantity 3 root 2 plus 2 quantity squared, right? So that is the calculated value for dt. And what would the units be? Well, it's the rate at which the distance is changing. So this would be in miles per hour.